Hello, I'm Conan Samuel, Chief Operating Officer here at Earlens. Thank you to FCOM for giving this opportunity for our team to walk you through the processes and technologies that we use to custom design and build each Earlens system for your patients. I'll be joined by Ali Logan, the Director of Custom Manufacturing, Veronica Brown, the Manager of Digital Manufacturing, and Torsten Kamira, the Director of New Product Introduction, to explain how innovations in design and manufacturing technology are used to create the Earlens system here in our facility in Menlo Park, California. In terms of disclosure, all participating presenters are employees of Earlens. For an overview of the system, let's turn things over to Ali in the manufacturing clean room.
Thanks, Conan. Hi, everyone. I'm Ali Logan. I am Director of Custom and Digital Manufacturing here at Earlens Corporation. The Earlens system is composed of three components that combine to deliver a great listening experience. These are the processor, the ear tip, and the lens. All our custom components are designed here in Menlo Park, California. Like all custom hearing devices, the design is based on the accuracy of the impression of the ear canal. However, unlike conventional hearing aids, the impression captures the entire ear canal, including the surface of the eardrum. So we worked with ENT physicians to develop processes and optimize materials that permit the physician to safely and comfortably obtain an impression of the entire ear. In addition to training our ENT partners on best practices and process techniques, we also offer feedback on impressions and tips regarding how to avoid key types of impression defects that may impact the fit and performance of our Earlens system.
The foundation of the Earlens system is an accurate and complete impression. Performed by the ear, nose, and throat physician, the Earlens impression captures the entire ear canal, including the surface of the eardrum. It is accomplished in two stages, combining two impression materials. First, after a thorough cleaning of the ear canal, a thin coating of mineral oil is applied to the ear canal and the surface of the eardrum using a cotton applicator while the patient is reclining in an exam chair. A low viscosity silicone material is then dispensed onto the surface of the TM, filling the interior sulcus and the canal to the bony cartilaginous junction. This material is allowed to cure briefly before returning to the patient to a sitting position. A second, higher viscosity silicone material is then dispensed into the ear canal, completing the impression and bonding securely to the first, medial impression. The impression is then easily removed from the ear and is sent to Earlens for scanning, design, and manufacturing of the custom Earlens system. Veronica Brown will walk us through this process.
Hi, my name is Veronica Brown, and I'm the manager of the Digital Manufacturing Group here at Earlens. The digital process is the first stage of our manufacturing, and it's split into two different areas, impression scanning and digital design. So in the first area, impression scanning, that's where we take the work that the physician has done and translate it into something that the digital design team can use. We have an example of one of our scanning setups right here, and in this, with this scanner, we scan at an accuracy of 20 microns, and that level of detail is important because the impression is the foundation of our final product. So as you can see here, we have the sulcus of the impression, and that translates directly to the final lens, and the canal of the impression translates directly to the final ear tip. And we have this example here of our impression defect guide showing what we do and don't want influencing that final product. So once we have the impression scanned, we then decimate it. That reduces the file size and simplifies areas that we don't need, and this allows us to move it through our processes a little bit faster. So once we have the impression scanned and prepared, that's when we'll go on to the actual digital design process, which is done in a proprietary software that we've developed called Earlens Builder. In Earlens Builder, we take the design of our product and fit it to the individual anatomy. So the first stage of our digital design process is feature selection. In digital environments, there's no gravity, there's no up, no down, so we need to find a way to orient this anatomy in the space. And the way that we do that is by selecting key anatomical features, which are then used later on in the process. So you can see here we've selected the umbo. We'll also be selecting the short process and a plane that represents around where the tympanic membrane is. So here we have that plane being selected. And then once we have all of those features, we move on to lens component placement. In the lens component placement, that's where we take all of the non-custom components and find the optimal position for them within the ear. So you can see here we have a preview of our perimeter platform, and then we're taking that drive post and the area where it connects to the umbo, and we're designing out from there. So here you can see moving around the receive coil, the motor mount, the motor, to try and find the optimal placement for a easy to deliver and comfortable lens. So the next phase in the process is the direct print chassis generation, also called DPC for short. We have this, and the DPC is the only 3D printed part in our final lens assembly, and this allows us to translate those placements of the different assets we've done in digital space into the physical space and accurately place all of the non-custom components. And you can see here where we are modifying that final DPC so that it fits exactly within the perimeter platform. Once we have the lens designed, we move on to the ear tip. So we use Earlens Builder for our ear tip design rather than a off-the-shelf software, so that it allows us to take into consideration the lens design as we're designing the ear tip. So we're designing one cohesive system. So you can see that's where the lens is in relation to the ear tip. And what's being shown here is the design of the mold that's actually going to get printed and used to make the final ear tip. Like I said earlier, the DPC is the only 3D printed part, so everything else that we design is then translated into molds and fixtures for our clean room to assemble. So once we have that final ear tip, we have an example right here. So we have the positioning lip, which sits in the contra bowl. Here's the vent and transmit coil placement, and all of these are custom ear tips, but we do modifications for fit and for comfort. And you can see here one of our final ear tips.
After digital design, the manufacturing process is picked up in the 3D print lab. For an overview of 3D printing technology and how it applies to Earlens, let's go to Torsten Kimura.
Hello, my name is Torsten Kimura. I'm the Director of New Product Introduction here at Earlens. Been working here about 7.5 years, so I've seen a lot of changes in the technology here, and I'm here to talk to you about the technology for 3D printing. In custom manufacturing, there are 3 stages that we go through here. There's the digital design, where they create all the designs on the computer, and they generate files that would come here to the 3D printing lab, which we print out all these different items. Then those items would get sent on to the manufacturing area to assemble the product. So the first thing I want to talk about is, what is 3D printing? There's all kinds of 3D printers out there, but in general, 3D printing is where you build up an object layer by layer. You're building it up. It's additive manufacturing. At Earlens, we use 2 different kinds of printers, both of which use a UV light source to cure a liquid resin to build up that object layer by layer. So first we have an SLA type of printer. That's the ones behind me here on the left. These are these workhorse printers of the industry. That uses a laser beam, a 20 micron wide laser beam, to draw an object in the surface of a liquid vat of resin. Then that elevator would go down, fresh resin goes on top, the laser draws the next layer, it goes down, draws a layer, and that's how it builds up layer by layer. Super precise. This is a high accuracy printer. The other printer that we use here is called a DLP style printer, a digital light projector, and that uses a projector to flash an entire layer at one time. As you can imagine, that's a lot faster than the SLA style printer, but up until recently, they haven't been as accurate. But just as your cell phones, your cameras, your TV get better and better resolution with each generation of technology, so also the DLP printers have been getting a lot better, and they're now about on par with the SLA style printer. So we have these carbon DLP printers here, and we have some ProJet SLA printers on this over behind me. They're both about 50 micron resolution printing. They use different resins. They use them for different things. And the ProJet printers, high capacity, you can print a lot of things on it. The DLP is a smaller print platform, so it can't print as many things, but they print faster. So they both have their advantages. From the design team, we get 10 different assets that we have to create. And if with traditional manufacturing methods, we'd have to make them one at a time. And that's really slow. That would take a long time to try to do. With 3D printing, we can take all 10 items and we can print them together in one run. And in fact, you can take the items from multiple ears, collect them all together, put them in the printer, and print them all together. So if you had like 15 ears and you had 10 items for each ear, that's 150 items. Better do it all in one print run than try to make them one at a time. So this really allows us to scale up efficiently. Next question is, well, how do we do this printing? You know, you can't just print these items off in space. They'll float away when we try to print them. What we have to do is we have to create like anchors, these little filaments that we call supports that tie the item to the print platform. And that's just little fine filaments that print together and support the item as we print it. When we're all done, we just break them all off and then we're good to go. So we talked about building up things layer by layer. What we do is we build it up, we set it all up in the computer, then we have the computer create slices of everything on that platform. And they're 50 micron slices. And just to give you a kind of perspective, a sheet of paper on average is about 75 microns. So we're printing very fine resolution. And if you have like a 1-inch tall item, that's about 500 layers. So we're getting a lot of detail in these items that we print here. So the computer will slice it up, and then we take all those slice files, compile them all together, and that gets sent over to the printer. The printer will then run through each slice file at a time, and it builds up your item layer by layer to make your object. Now I have here a video, a time-lapse video, printing a giant breakaway mold for the ear tip. And this mold, this item, it's giant. It's about the size of my fist. And it's printing out on the printer. And the first thing you see the platform coming up, and there are the supports. Those supports are what hold the object. And then it's going to print out the rest of our breakaway mold. Again, this is time-lapse, right? If an object about this big would take 5-6 hours to print. It's high speed, but still, it's 50 micron layers. It takes a lot of time to print. So we did a time-lapse video so you can actually see what it looks like as we're printing something coming out of the vat of resin.
Once the 3D printed components have been generated, processed, and prepped, they are then moved on to our clean room environment for assembly, testing, and packaging. Ali?
Hello everyone, my name is Ali Logan. I'm Director of Digital and Custom Manufacturing here at Earlens, and I'm going to walk you through the final portion of the manufacturing assembly portion process in custom assembly. All of our printed components arrive to the clean room at 6 a.m. We have a team of 3D printing technicians that arrive at 3 a.m. to post-process any of the parts that came off the 3D printer and delivers them at 6 a.m. We are, at this stage, taking the 3D printed components and incorporating the electromechanical components into the final assembly. So first I'm going to walk you through the tympanic lens assembly. The tympanic lens assembly has 12 main components: the electromechanical subassembly, the 3D printed chassis, the perimeter platform, and the umbo platform are the main components. As you have heard about previously with the digital design and 3D printing, we have a number of 3D printed components that are generated from the impression. These are the components that are coming to the clean room at 6 a.m. As you can see here, there's about 7 components that go into the tympanic lens assembly specifically. First, we start by taking the blow mold and UMBO blow mold 3D printed components and take a silicone tubing that we insert inside of that. We use a blow molding process which uses heat and pressure to expand that silicone tubing so it takes the shape of the 3D printed component. We then trim along a set line that is generated specific to the platform to ensure increased retention on ear for that specific patient. We also have a custom direct print chassis. Again, this is unique to every single device and each individual. This is to ensure that our electromechanical components are in a precise location. We want to ensure we get maximum output and are driving the UMBO at the deepest point. We also have customized drive post lengths to accommodate those various lengths in the UMBO depth. We have 3 different drive post lengths to accommodate multiple depths of UMBOs. Our smallest drive post cannot be seen with the naked eye, and it requires a microscope to be able to see. We do a similar process to the perimeter platform that we do for the UMBO. We generate using blow mold process with the silicone tubing. We then use a precision die to cut the blow mold in order to ensure that it's exactly the diameter for maximum output on the tympanic membrane. In order to identify right and left, we apply a color indicator, red and blue, just like industry standard, left for blue, red for right. We do 100% inspection of all of our products. We start by doing a digital 3D scan of the lens to ensure that the components on the manufactured unit are within 100 microns of the digital design. This is to ensure, again, that the components are in a precise location for maximum output. We use the principle of laser Doppler vibrometry in order to do a 100% inspection of output and distortion on our device. We look at and evaluate from 100 Hertz to 10 kilohertz and ensure that our output is above a certain threshold and our distortion is below our required threshold. We place the final device into a 3D printed component specific for that lens so that it arrives safely at the clinician's office. Now I will walk you through the ear tip assembly. The ear tip assembly has 2 main components, the TX coil cable subassembly and the silicone shell. We have 3 3D printed components that are digitally designed and from the impression that are supplied to the clean room. We take the 3D printed shell and inject silicone into it and cure with heat and pressure, and then break away that outer shell in order to have the custom ear tip. We Dremel the shell to make sure that there aren't any sharp edges and we have a good finish. We laser etch each shell with a serial number and then apply a colored dot, the red and blue indicators, in order to indicate right and left, but also help with orientation and insertion. There are 18 different cable lengths. This is obviously decided at the initial appointment and measured by the audiologist. This is supplied to us and we attach the cable to the silicone shell. We perform 100% inspection of our ear tips by ensuring that they're functioning properly. We're doing a signal output and tuning frequency check on all of our ear tips. We attach a processor to the ear tip, enable an iPhone license onto it, and enable Bluetooth. We put the processors into deep sleep mode to ensure that they are charged upon arrival at the clinic. Once the ear tip and the lens are complete, we package them into our inductive system packaging. This includes many accessories, including a charger, oil, and along with the processor, ear tip, and lens, a case. Once finally packaged, everything is delivered to our shipping department and ready to go to be sent off to your clinic. Thank you all for joining us today, and I'll pass it back to you, Conan.
As you can see, there are a wide variety of unique and innovative technologies involved in the design and manufacture of a unique and innovative product. We hope that you've enjoyed learning about how the Earlens system is manufactured, and we look forward to the opportunity to work with you and your practice in delivering cutting-edge hearing healthcare to your patients. Thank you for attending today's session.
Hello, my name is Dave Fabry, and I'll be presenting today on the evolution of the use of artificial intelligence in the professional and patient experience. And my disclosures, first of all, I'm the Chief Innovation Officer, as I mentioned, at Starkey. I've divided my career equally between academic and industry roles. I'm delighted to be back speaking at FCOM today. My disclosures include that role at Starkey. I'm on the executive team. I am also serving currently on the board of directors for the American Auditory Society, and I'm a board member for Envoy Medical. One thing that I think it makes sense to consider first is why we're using artificial intelligence, and that is when we look at what it is that hearing aid users expect from modern hearing aids. This from the Market Track 10 survey, most recent one in 2019. The top 4 drivers are natural sound quality and speech intelligibility, in particular, to minimize background noise when it's present, providing comfort for loud sounds, and then spatial awareness. I want to focus my first part of this discussion on the use of artificial intelligence as it relates in hearing aids to mimic and surpass human intelligence by first defining the way it is that we characterize artificial intelligence. The classic sense used to mimic normal intelligence or natural intelligence is really to consider and step back for a moment that we don't hear with our ears any more than we do with any of our other senses, pick up those sight or taste or touch or smell, but rather we're providing inputs to the brain where it can be integrated across in terms of multimodality. Hearing and vision are very intertwined, where it can be integrated, processed, and then act on a set of rules, if you will, that in the true sense of the Turing definition of our AI, which I'll come to in a moment, the machine in this case can actually learn from past experience. And Alan Turing in 1950 provided the classic definition for AI, now known as the Turing test, is a test of a machine's ability to exhibit intelligent behavior that is equivalent to or indistinguishable from that of a human. The way we consider AI, because I would say that the term has become ubiquitous and at the same time meaningless because it is so overused now. I want to think of it the way we talk about it as an overarching definition of subsets that can include machine learning, that is a collection of algorithms whose performance improves as they're exposed to more data over time. And then a further subset within the umbrella of AI is deep learning or deep neural networks, in which multi-layered neural networks actually learn from vast amounts of data. In both of the examples given here, machine learning and deep learning, the fundamental element that improves AI is large data sets. We've been using AI-based sound classification in the hearing aid industry for, I would say, the last decade or so. If the goal is to have automated processing, that when a hearing aid user is wearing their devices, they can go from quiet to noisy environments, or even listen to music or protect against loud sounds. Only those features are incorporated in the appropriate acoustic scene, and I've shown several here. And we've really moved toward that as a goal, rather than individuals having to change from individual programs dedicated to specific purposes. That being the case, what happens in an algorithm of a machine learning classification system is we take sound inputs like you see here on the left, and then provide certain features, spectral features, temporal separation features that differentiate between quiet, speech, noise, and musical environments to post-process and come up with classifications, channels, if you will, acoustic scenes that are shown on the last slide as separate acoustic environments for then which hearing aid processing is incorporated. We know that, and really looking in this cartoon, what you see is that if we have just a 2 feature scene shown here, that on the basis of differentiating between the 5 or 6 different scenes that we've characterized in this cartoon example, that we can successfully differentiate using as few as 2 scenes to try to then expose to real world acoustic environments to see how they're classified into that quiet or noisy or musical environment. And what we know is that despite the fact that you've seen in this cartoon the way that they're separated out on the basis of these scenes, the more features that we have, the more separation and less overlap between the scenes, as you see that cluster in the middle of the characterization here. Because the reality of the situation is that even under the best of circumstances, the most accurate machine learning systems are only accurate about 80% of the time for acoustic environments. And that's really depicted in this scene, if you will, this acoustic environment from New Orleans on Bourbon Street. If we were walking down this street and engaged in a conversation, you'd see that we might encounter other individuals, other voices. Some may be loud and boisterous that we want to suppress rather than enhance. And then you also see the gentleman playing the guitar in the front. He could be a signal of interest if he was any good, or he might be noise if we were engrossed in conversation with someone that we wanted to speak with. What I mean by showing this characterization, this acoustic environment, is that speech can be both a stimulus or a noise, as can music be both a target of interest, or if we're in an elevator engaged in a conversation and there's music piped in overhead that is undesirable, the acoustic classifier really doesn't have that additional intelligence to discern when speech is a signal of interest or background noise, when music is a signal of interest or background noise. Hence, artificial intelligence can only go so far in making those kinds of attributes to separate out and classify more than 80% of the time. We developed an AI feature that allows the individual to engage in this. And we say that artificial intelligence is no match for the human brain yet and human empathy in terms of the individual being able to double tap on the device or press a button when they're in a challenging environment to characterize that acoustic environment in terms of an acoustic snapshot at that moment for the signal of interest that's in front of them. In this way, we're really combining AI with the individual's intent for communication in a challenging environment. The way that this is taken on and incorporated in hearing aids is the user requests assistance by pushing a button on the hearing aid or in a user app. The environment is detected and parameters are retrieved specific to that environment, and the listener's intent in turn then can enable that characterization and optimization to that specific environment. And then the user can either reject that enhancement or optimization and go with the automated classification, or select it if it's an improvement over what the machine learning AI algorithm could do in that environment. What we have seen in developing this is that this edge mode AI enhancement on the basis of the patient is preferred over the all-around acoustic classifier by a significant degree. And I'll give you another example of the way that we were able to innovate almost in real time during the pandemic, when people started encountering other individuals who were wearing masks as well as wearing masks themselves in the interest of protecting their health and safety. In this case, I still work with patients today, and I started having patients in the second quarter of last year come back and say, edge mode, you told me that AI intent, if you will, that user optimized AI feature was designed for noisy environments, but I found that when I'm communicating with individuals wearing face masks, I'm actually hearing them more clearly. So I went into the laboratory and began to look at how audibility of speech was impacted by social distancing, the use of a face mask, even the type of a face mask, and whether background noise was present. Another important sort of collateral issue with face masks is the loss of visual cues for masks like the one you see in the picture here, where facial cues are obscured by the fabric in the mask. This curve represents just a subset of the dozens and dozens of face masks, medical grade face masks, fabric, even some of the more emerging popular masks that use a clear plastic panel, and what their acoustic impact on speech audibility was. The important take-home message from this curve is that while all masks attenuate speech, they do so to varying degrees. Medical grade masks like the N95 mask that you see depicted in this curve attenuate about 6 dB in the high frequencies that are important for consonant information, and still about 2 dB in the low frequencies. Some of the other fabric masks reduce speech audibility to a lower degree. And one of the surprising findings we found was that for the mask in the clear plastic panel that you see with the shield in gray here, is that it introduces a sharp resonance that provides actually enhancement of speech in the low frequencies, but then a sharp anti-resonance at around 4,000 hertz, reducing speech by 5 dB or more. So bottom line is all masks are not created equal, and to varying degrees, they are attenuating speech and making it more difficult for people with normal hearing, and certainly for those with hearing loss and even hearing aid users to understand speech. Now, some individuals and some manufacturers have come up with sort of an offset just to apply to what an average mask would do. But we decided to take one step further and use AI to optimize, to compensate for any face mask type, social distance, or background noise by having the user, when they enter into communication with someone who's wearing a face mask, press a button, double tap, or press a button in the app to optimize for that person in front of them at the social distancing that they're at in that environment, with the type of face mask they're using and whether or not background noise is present, optimizing using directional microphones. What I want to do is to give you an audio demonstration of this in 3 samples. First, when a woman is talking at about a 5 dB signal to noise ratio with no mask worn at a distance of about 3 feet for conditions with a mild to moderate degree of hearing loss applied in a hearing aid. And what you're hearing is the output of the hearing aid in this rather challenging listening environment.
The rainbow is a division of white light into many beautiful colors. These take the shape of a long round arch with its top light back and its 2 ends completely round the horizon.
Now I'm going to go to the second comparison and add a face mask in this case. And what you'll hear is indeed those fricative high frequency sounds are more attenuated than in the previous example.
The rainbow is a division of white light into many beautiful colors. These take the shape of a long round arch with its top light back and its 2 ends completely round the horizon.
In the third example, all things will be the same as the previous 2, but now we've activated the AI-enabled edge mode to enhance for social distancing, the presence of noise, and the type of mask is worn. See if it isn't a little easier to understand than the previous 2 examples.
The rainbow is a division of white light into many beautiful colors. These take the shape of a long round arch with its cap high above and its 2 ends apparently beyond the horizon.
Now, I know we're taking a little risk with those of you listening remotely. And so what I've done here is to plot, actually, the 0 line shows that first audio condition that you heard when no mask was worn, but we were applying gain appropriate for a mild to moderate degree of loss. This orange curve shows the attenuation in the high frequencies when that face mask was worn in the normal all-around machine learning classification system. And then the final condition, hopefully it came through on the audio example, was when that AI enhancement edge mode was used with the face mask present, and it actually provided more audibility than when no mask was worn at all. And in studies that we've conducted, we found a strong preference for this edge mode when face masks are being used. And it was really, we launched this feature prior to the pandemic. It had a serendipitous benefit for those communicating with face masks and encountering other individuals with face masks during the pandemic. For more information on the way that we're using artificial intelligence increasingly in hearing aids, there's a special issue of Seminars in Hearing that was just published this month in October, and it has open access. So you can go to Seminars in Hearing and receive all of the special articles in this paper that cover some other manufacturers' use and incorporation of AI to improve speech understanding in noise. And if you'd also like to contact me to receive the paper at the end of this presentation, please email me and I can send it to you. Now, the other thing that I want to talk about in ways that we're seeing AI begin to be incorporated in wearable hearing aids is through the use of embedded sensors or inertial measurement units directly in behind the ear RIC or even custom hearing aids that are capable of detecting motion. And like you have with wrist-worn tracking devices, they can track physical activity. Why is that important in a hearing aid? We know from recent studies, this one from JAMA in 2021, earlier this year, found that every 10 dB increase in hearing loss, people spend 8.5 more minutes per day being sedentary. What that translates into is a lifetime of accelerated aging by about 5 to 7 years relative to the normal hearing counterpart in that aging population. So we want to encourage people to be more physically active by wearing their instruments and actually just wear the hearing aids. We can track and display in a user app the number of steps that they've taken, whether they've exercised, whether they're getting up and moving around a little bit every hour for musculoskeletal strength. In addition, we're tracking use of the hearing aids automatically and reporting it in the app, and also the interaction, the social engagement with other individuals throughout the day by tapping into that acoustic environmental classification and gamifying it, if you will, to encourage and motivate people to be wearing their devices, be more socially engaged, and encounter different environments throughout the day. That, in combination with the physical activity, really enables and incorporates the use of machine learning and artificial intelligence models to encourage people to be more physically active and socially engaged with their devices. The last thing I want to briefly talk about is the way that we've incorporated a fall detection algorithm in the hearing aid by using that IMU sensor in combination with algorithms that can actually detect when the person is wearing their hearing aids and if they unfortunately suffer a fall. We've evaluated, and I also can direct you to white paper and peer-reviewed publications that compare the sensitivity and specificity of these ear-level devices compared with the popular chest-worn devices, and find greater sensitivity and specificity for fall detection because we're using 2 devices that are capable of detecting a fall rather than one on the chest, and then alerting via a smartphone a text message to up to 3 trusted contacts that can receive a notification if a fall took place, and even using location services, see on a map where that individual was when they fell. So in summary, AI-enabled hearing aids improve hearing aid performance in challenging listening environments by using machine learning and human engagement. Hearing aids using embedded sensors and artificial intelligence are capable now of monitoring physical activity and social engagement, as well as detecting falls and alerting trusted contacts of those falls to keep their loved ones safe and well. So thank you very much for the opportunity to present at this year's FCOM. If you have any questions or comments for me or would like additional details, please use my email to contact me.
Thank you for joining me for today's presentation, Widex Moment, Uncompromised Sound, the ingredients that make natural sound from a hearing aid possible. I'm Dr. Susan DeBond, Senior Clinical Product Specialist with Widex US. My audiology experience spans 30 plus years, including ENT, neuro-otology, audiology private practice ownership and management, as well as 10 years as a product specialist and trainer with 2 global hearing aid manufacturers. My current employment with Widex began in April of 2015 as a professional education manager. I received my Master's of Science degree in audiology at the University of South Florida and my doctorate in audiology at the University of Florida in 2000. I'm a licensed audiologist in the state of Florida, a fellow of the American Academy of Audiology, and a member of the Florida Academy of Audiology. To disclose, I am an employee of Widex and receive financial compensation, but I have no disclosures or conflicts of interest with presented material in this presentation. The role of amplification in treatment of hearing loss and the resulting effects on cognition and general well-being of the wearer are increasingly recognized. Specific hearing aid features do play an important part in acceptance and consistent use of hearing technology. In this presentation, we will look at the Widex sound processing features that support the goal of natural, uncompromised sound and explore the ingredients contributing to natural sound, with specific focus on how processing delay in a hearing aid affects the user's experience with and acceptance of amplification. As we explore the ingredients of natural sound from a hearing aid, it makes sense to think of how hearing aids are a lot like food. Food delivers nutrients and energy to our bodies. Hearing aids deliver acoustic information from our environment to our brain. Our bodies process food most efficiently when the food is in a natural state. Our brains process acoustic information most efficiently when that amplified information is as close as possible to the original natural sound. Food that is overly processed and containing man-made additives can negatively impact health, taking significantly more energy to digest and offering sometimes less nutrition. Amplified sound that is processed too slowly or that compromises or distorts acoustic information takes more energy for the brain to use and negatively impacts the ease of listening. Let's not forget that our end goal is to foster our patients' social participation in life by minimizing the negative impacts of their hearing loss. We understand that the role of technology is not only about audition, but also encompasses managing their listening effort and listening fatigue. Technology that supports earlier and quicker acceptance and use of hearing aids benefits the patient's cognitive, social, and emotional health by empowering social participation. It's a great thing that today's patients are more proactive and engaged with their healthcare than in the past. They are better educated about hearing healthcare and have high expectations of technology solutions. By being more proactive, prospective new hearing aid wearers should be looking to maintain and protect their health with hearing aids that are comfortable to wear, convenient to use, and most importantly, provide sound so natural that they can put them on and forget about their hearing difficulties. In other words, hearing aids that let them stay active in the game of life. So how do we get to the end result of natural amplified sound? And what are the main ingredients or processing features that must be considered to avoid adding man-made distortions that compromise the experience of natural sound? Natural sound starts with innovative design. So let's look more closely at 3 of Widex's feature innovations. Widex's approach to sound quality starts at the beginning as sound enters the processor, at the input stage, by ensuring accurate measurement of the acoustic environment for extremely soft sounds at 5 dB SPL, as well as loud sounds like loud conversation in a noisy restaurant up to 113 dB SPL, and maintains linear measurement throughout that 108 dB input range, maintaining the fidelity and the definition of natural sound. In addition to measurement of the frequency and intensity of the acoustic environment, sampling the environment quickly enough, 32,000 times per second to be exact, to capture the changing subtle details over time, make sure the amplified sound matches the original sound as closely as possible. Widex's unique use of frequency, intensity, and time filter banks preserve the range and quickly changing details of natural sound, guaranteeing that we are not introducing distortions before we get to the processing stage. Now let's talk about the speed of processing. This stage, where applying needed gain, addressing noise, and direction of sound all take place, becomes even more important when the hearing aid fitting is open or semi-open, which allows natural sound and amplified sound to mix at the eardrum. The speed of the hearing aid processing, called throughput delay, influences perceived sound quality and the brain's ability to recognize and use that information, as we shall see. The Widex Moment is the industry's first hearing aid offering two separate sound processing pathway options within a single hearing aid. Many hearing aids sound artificial because of the audible detectable delay, often resulting in listening frustration and refusal to wear the hearing aids. Delivering a truer signal by minimizing the processing delay allows the brain to recognize and use the signal more easily and makes the hearing aid sound more appealing. Why does a hearing aid sound like a hearing aid? And how does this hearing aid sound contribute to other sound complaints like, my own voice sounds strange, the sound is harsh, microphony, or it echoes? Let's call it the hearing aid industry's best kept secret, the comb filter effect. In simple terms, the processing speed or delay causes the amplified sound from the hearing aid to arrive in the ear canal slightly later than the sound entering the ear canal directly through the ear tip. This mismatched timing means the two sound signals combine out of phase. Sometimes the signals are added together, sometimes they cancel each other out, what we call constructive or destructive interference. And this resulting combined signal is distorted. We are so familiar with how this comb filter distortion sounds, in fact, that we would recognize this as the sound of a hearing aid. That sound quality, we've had to tell patients, you'll eventually get used to it. We know that with delays from 5 milliseconds to 10 milliseconds, depending on the signal, there is the potential to detect echo-like sounds, a noticeable difference between the direct sounds reaching the ear through a vent and the sound from the hearing aid. Other top hearing aid manufacturers, shown here in brown, green, and red, operate between 5 milliseconds to 8 milliseconds of delay. Widex has always designed and built their own chipsets using 3 filter banks: frequency, intensity, and time. And the Universal's program processing throughput speed is 2.5 milliseconds, about twice as fast as our closest competitor. But even though that market-leading low delay of 2.5 milliseconds sounded great, we knew that end users with mild to moderate hearing losses with vented or open fittings were still potentially exposed to sound quality effects of delay. So we got to work trying to reduce it even further, far below what had been possible before. The result, the fastest digital hearing aid processing. Pure sound processing pathway cuts delay to 0.5 milliseconds, 10 times faster than our closest competitor, and dramatically reduces the final artifacts experienced due to the comb filter effect. Pure Sound's zero delay technology eliminates the timing mismatch between natural sound and amplified sound reaching the eardrum, and negates its resulting sound quality distortions experienced by the hearing aid user. Eradicating delay-based distortions allowed listeners to describe pure sound as less noisy, more natural, clearer, even as compared to the universal's 2.5 millisecond pathway. Pure sound's dramatic decrease in throughput delay to 0.5 milliseconds can be measured not only in the hearing aid, but also in the ear through real ear measurement with curve smoothing turned off, and at the level of the brain. Use of EEG to measure the phase lock or rate code transfer of auditory neurons envelope following response allows us to measure the brain's transfer of temporal information. The literature suggests that the more robust EFR is associated with better speech understanding and noise abilities. Looking at the EFR with differing hearing aid processing delay times demonstrates better neural representation with shorter delays. This may contribute to a more natural sound experience and potentially less effortful listening. Studies conducted on the neural encoding of speech were performed at the Office of Research in Clinical Amplification and published by Dr. Francis Cook in 2020. Check out his course on audiology online for full details. It's course number 36329, titled Widex Moment Pure Sound Innovations and Influence on Cognition. In this particular study, neural encoding of speech with pure sound versus premium hearing aids from two other manufacturers were compared. All were programmed to an NAL-NL2 target with default feature settings in place, and all were fit with open instant ear tips. The key question was, how is the speech stimulus envelope encoded in the brain? This was revealed by analysis of the envelope following response, the EFR, seen in the red recording on top here. This EFR provides focus on activity of auditory neurons and how they encode the fundamental frequency of speech. Using the envelope following response to measure the neural response to speech, EFRs were obtained through a hearing aid with an 8 millisecond delay, shown in green, a 6 millisecond delay, shown in pink, and pure sound's 0.5 millisecond delay, shown here on the bottom in blue. The amplitude and peak timing of the EFR waveform showed more accurate encoding of sound, a closer match to natural sound, with pure sound's 0.5 milliseconds processing speed. The longer hearing aid delays of 6 milliseconds and 8 milliseconds distorted or degraded the neural tracking of a sound's temporal envelope. Additional studies suggest less distortion of the EFR may also be associated with less effortful listening and more robust speech comprehension. Faithful neural representation may also contribute to the sound quality preferences for pure sound shown in our other studies. One of these other recent studies of a hearing aid user's subjective satisfaction and preference of Widex Moments universal and pure sound processing confirms the importance of sound quality. This study evaluated both the user's satisfaction in hearing aid sound quality and their perceived ability to participate in daily life with the use of hearing aids. Participating were over 101 experienced hearing aid users from 7 different countries in a crossover design study that took place over a 7-week survey period. 91% judged Moments sound quality in the satisfied to very satisfied range, outperforming their own current hearing aids. In regards to participation in daily activities with hearing aids, 90% felt Moments sound quality provided higher satisfaction as compared to their own current hearing aids. In summary, the faster throughput speed of 0.5 milliseconds delivers a truer signal to the brain, one which the brain may more readily recognize, decode, and process, while also providing a more natural, amplified sound quality experience for the listener. So why does throughput speed and processing delay warrant our attention? Why should we care about the comb filter effect? Let's think about the percentage of our hearing aid fittings that are potentially open or semi-open fits, specifically RIC style fittings. In 2020, 79% of all hearing aid fittings in the US were RIC styles. And what percentage of our RIC fittings are completed with domes? Domes which have the potential to be much more open and fitting than we might expect. These fittings stand to greatly benefit from reduced delay distortions, which may also lead to more immediate acceptance and wear because of a more natural sound experience. Let's also consider where we may have more opportunity. When we are looking at the scope of untreated hearing loss, shown here in gray for each degree of loss, and we take into consideration the potential combination of patients being more proactive about their hearing loss and cognitive health, and the potential to provide higher satisfaction with minimized delay, particularly for those early adopters with mild hearing loss, of which 90% are untreated. It becomes a win-win opportunity for both patients and hearing healthcare providers alike. Hearing aids that provide more natural sound are likely to be accepted more quickly and might be used more consistently. And evidence shows that wear of appropriately fitted hearing aids can decrease hearing loss-related cognitive risks and support more active social participation. This same opportunity may be true even for those with more moderate loss if fit open or semi-open. Half of those with moderate loss are not yet wearing hearing aids. To wrap up, ingredients to natural sound through a hearing aid include attention to input fidelity in frequency, intensity, and time spectrums, and minimizing processing delay, and performance features that can meet the needs of the individual patient. These ingredients support an ease of listening that leads to the benefits of cognitive and social engagement, which can restore the joy of participation. We recognize that the quality of sound that we deliver to the ear and the brain can have significant impact on the ease of listening in both quiet and challenging listening situations. More natural sound quality from a hearing aid could lead to quicker acceptance, more consistent wear, and adaptation. Widex Moment's Pure Sound 0.5 milliseconds processing speed is designed to support the goal of uncompromised sound quality, recognizing the cognitive benefits as well as the social and emotional health benefits to remaining engaged with family, friends, and coworkers. I thank you for listening today, and please feel free to reach out to me with any questions about Widex Moment and Pure Sound benefits at susan.debont@widexsound.com.
Today, we are going to talk about all things Bluetooth, tips for successful pairing, as well as troubleshooting with our Unitron hearing instruments. My name is Christina Petritis, and I am the Audiology and Education Manager here at Unitron. And I have had the joy to be with Unitron for almost 5 years. My favorite sound, cheers at the triathlon finish line. Feel free to add in the chat what your favorite sound is. And lastly, before kicking off talking everything about Bluetooth, you'll see my listed disclosures here. So, how comfortable, confident do you feel in your Bluetooth connectivity skills? Our goal for today is to give you smooth experiences with connectivity with some reminders regarding best practices related to Bluetooth and pairing processes, and then to share some tips and tricks and other troubleshooting suggestions. Our profession continues to change, and now, along with being hearing care experts, we need to become IT experts when it comes to pairing and connectivity. According to Pew Research, as of 2019, 81% of all Americans own a smartphone. Now, even though the 65 plus population has the lowest adoption rate at 50%, if we look at historic data, we can see that the adoption rate in this segment is trending upwards in this age bracket, noticed in the red bar, from 30% ownership 5 years ago approximately to now 53%. In fact, our over 50 population had the most growth in general, with a 23% growth in our baby boomers and a 21% growth in our Gen Xers. And how has COVID-19 impacted our connectivity? A survey by the News Stack in June of 2020 looked at just that and found by generation, 43% of baby boomers reported an increase in mobile phone use, as well as a 27% increase in laptop and 31% increase in desktop use. And when we look at the US smartphone market, it has really boiled down to two camps of technology: those who use the Apple iOS technology and those who use smartphones based on the Android platform. So not only do we have to think about what product would best serve your client in terms of their audiological needs, dexterity considerations, lifestyle, etc., we also need to consider what type of phone technology they use. Are they smartphone users? What type? Are they flip phone users? Fortunately, the type of phone a client has does not have to restrict the choice of hearing aid technology you recommend, because Unitron has all the connections, and our latest platform, Blue, provides your client with all the connections, starting off by Sonova still offering the only wireless chipset in the industry that provides direct connection options for both Android and Apple iOS users that are still not possible with the current offerings from other manufacturers. Some manufacturers are claiming made-for-all functionality, but when you look into the details further, this usually applies only to the use of the app, not calls or media streaming. The ASHA protocol is slowly becoming more widely available with some Android phones, but it's still not an option for many and is not hands-free. The Prism chip, which powers Blue, is truly made for all and truly hands-free. So let's focus on the Bluetooth protocols within the Prism chip. Bluetooth Classic with the hands-free profile, and Bluetooth Classic A2DP. And lastly, we'll look at the Bluetooth Low Energy. So let's start with what could be considered the first question. Does Made for All include my client's phone? Because we support our hearing instruments with Bluetooth Classic, we support a wide variety of phones, even older version phones, be it Android, Apple, or flip phones. How can you verify? Easily check through our phone compatibility web portal. If you haven't yet previously bookmarked the smartphone compatibility webpage, you can access it via the TrueFit fitting software. It would be under Instruments, and then this selection, and then in the center, there is this Check Smartphone Compatibility link. You are then brought to a website where you simply type the phone in the free text field as shown above and click Enter Return. It provides you with the details, and then scrolling down, the search will provide compatibility for the model of phone you entered for both phone calls and Remote Plus app functionality, as well as instructional tutorial videos. It really is that simple. Now you know that your client's phone is compatible with Unitron hearing instruments. While programming, you can change the Bluetooth side if needed. What is meant by Bluetooth side? When programming a set of Blue hearing instruments, one ear in the fitting will be designated as the Bluetooth ear for that fitting. This doesn't impact sound quality for the client, but it does determine which hearing instrument will be paired to the client's phone. And it also determines which hearing instrument microphones will be used to pick up the user's voice when they are on a phone call. You can find this setting in End-Fitting Hearing Instrument Setup by selecting the drop-down arrow to the right of right to change the phone ear to then maybe the left ear. In addition, you can change the name of the hearing instrument when locating it in the Bluetooth phone menu. So after programming and closing out of the TrueFit fitting software, you're ready to pair. Let's go through the recommended sequence to ensure minimal loss of Bluetooth connection down the road. This sequence is based on what all you are providing for your client. Potentially, you could be pairing for phone media connectivity, for app connectivity, and/or to pair the hearing instruments with an additional accessory solution. First thing, pair to the phone. Because we use Bluetooth Classic protocols, the phone media streaming pairing is going to be done within the Bluetooth settings of the phone for both Android and iOS phones. Pairing is not done in the accessibility menu. So you would click on Settings, click on Bluetooth. It will discover the one hearing instrument you selected as the Bluetooth side. For this example, MD Right HA. Once discoverable, click on it, and you have successfully paired phone to the phone media streaming. So you've just paired to your client's phone. If you're going to set up the app for a client, this would be the next step after the phone pairing is complete. Download the app through the Apple Store or Google Play Store and go through the setup process. Accept the privacy policy, pair the hearing instruments, choose to activate insights, and once complete, your client will have the benefits of remote control with equalizer functionality at their fingertips, plus plenty more. And you are able to see if the pairing of the phone and Remote Plus app are done correctly under the Bluetooth settings of the phone. You should see a total number of 3. Our hearing aid, that indicates you're paired to the phone using the Bluetooth Classic. LE, L, and LER hearing aid. It's paired to the Remote Plus app, with LE meaning low energy, which is the Bluetooth protocol used to connect to the Remote Plus app. So we've successfully paired to the phone and app. Last pairing, if required, would be to any solutions, which is simply done by pressing the pairing button on these accessories. So what you've just seen is, a total where there should be 3 Bluetooth devices for a binaural fit and while it's been paired to the phone and app. And I want to reiterate this. So under the Bluetooth My Devices, I want to make sure it's understood that it is meant to show also not connected for the Bluetooth LE connections, because you cannot have the Remote Plus app open at the same time you're reviewing the Bluetooth menu. So what would you do if the client reports connectivity difficulty at this time? So you verify that all Bluetooth devices are successfully connected. What you would be encouraged to do is that the phone benefits an overall performance being turned off completely, like truly power off and rebooted regularly. It might be because connection could be disrupted if memory on the phone is almost full. How many apps are open? Make sure to swipe away apps to close them out. And if connectivity issues continues, delete Bluetooth pairings, removing from the app and removing from the Bluetooth settings from the phone, and start over. So let's review some troubleshooting tips. So if your client reports concerns with call quality, especially my iPhone has a static sound, the hissing or static for the iPhone could be a result that some of the later iPhone smartphones have hands-free profile issues. Therefore, switching the bandwidth from adaptive to fixed, there's 2 ways that this can be adjusted. The first way, clinicians can adjust this within the TrueFit fitting software under end fitting, hearing instruments, setup, and then Bluetooth. Or conveniently for your client within the Remote Plus app under menu, the burger menu, My Hearing Aids, and then the adaptive Bluetooth. I do suggest if hissing static is still present, suggest to pair to another phone to see if this issue persists with a different phone. So if adjusting the bandwidth did not address the issue, you may also want to verify the iOS is up to date. Current iOS version is 14.7.1. Last resort, if hissing or static continues, reset the network settings. This is located within the phone setting menu. General, scroll down to reset, and then select Reset Network Settings. But please note that resetting network settings will reset cellular network, thus stored passwords for Wi-Fi, VPN, and APN settings will be lost. So what happens if your client says, my calls cut in and out, or my calls are intermittent? Well, here's something that not everyone thinks about. Many calls are on Wi-Fi, especially as our lives have transitioned to be more to home. So what if your client has previously logged into Starbucks Wi-Fi and are on a call while leaving, distancing them from the store? It weakens that Wi-Fi signal. Thus, the phone call is compromised. Or like me, you're working from home and then you transition to go outside and enjoy the outdoors riding your bike. If you were on a phone call, it would still maybe be disrupted. To resolve it, consider switching to cellular by disabling nearby Wi-Fi. Another occurrence, event-driven system sounds. Those are your text notification, calendar reminders, can cause the phone to generate sound, which triggers the hearing instrument to switch to the media nav streaming programs. When this happens, the hearing aid microphones attenuate to focus on the streaming signal. For the client, they can perceive this as the hearing aids being intermittent or cutting in and out. There are a variety of events that can cause this type of reaction. Some are more obvious than others. Disabling app system notifications can prevent this from happening. You would go to Settings, Notifications, and you'll see a list of all apps on the phone and their responding notification settings. If you have an idea of which event app is causing problems for your client, you can go in and find the specific app which is causing the most issues. And you can simply turn off those notifications and questions to prevent the hearing aids from switching. This can be the simple fix, but it might be too global. Client still wants to get the pop-up notification, just doesn't need the audio connection. So it is possible also to go into the notification settings for the apps in question and disable the sound associated with the notice. That way, they can still get the banner or lock screen notification, just not the sound. And a couple suggested best practices. It is highly recommended to power down the phone daily, a full restart. Remember, smartphones are like computers, and rebooting is still the most effective way of solving many of the day-to-day errors which we encounter. And/or disable and enable Bluetooth dailies from the settings. Incoming call audio is set to automatic by default, and that means it will route based on how the call is answered. So if your client says, "I can't hear the caller when I answer my phone," this could be due to a call routing issue. To change call routing to always route to the hearing instrument for the iPhones, go to the Settings, Accessibility, Touch, Call Audio Routing, and then Bluetooth headset. So at Unitron, we do supply you with great resources. As an additional resource, we have a programming and pairing guide that offers step-by-step instructions with images to pair to phone, Remote Plus app, accessories, and other useful tips. And if all else fails, working through with your clients these troubleshooting tips, your clients can contact the consumer hotline. Either of these materials can be forwarded as a PDF, or you can order them from My Unitron, or reach out to your account representative who will happily get these materials for you. So how do you feel about Bluetooth now? If you feel, write something in the chat, a key takeaway that you learned from today. So really, there's no need to feel blue about Bluetooth. I want to thank you all for your time today. And if you have a need to reach out to me, that's my best email contact to get in touch. Thank you so much.
Thank you for joining me today to learn about Paradise, Innovation Verified in Benefits. My name is Allie Hoffman, and I'm a clinical trainer with Phonak. I've been with the company for 6 years, and prior to joining, I worked clinically in an ENT practice. As a result of today's presentation, you will be able to identify all of the technological improvements that we have made aiming towards performance in quiet, performance in noise, and also providing a natural sound quality. You'll be able to identify the extent of connectivity that's available to patients through Phonak hearing aids, and you'll also be able to list all of the use cases for universal connectivity with tap control. At Phonak, we are proud to support you and your patients through technological innovation and audiological leadership and offering the widest, most sophisticated hearing technology portfolio. From protecting one's hearing to treating hearing loss of any severity, we have a product that can meet that need. Additionally, we partner with Advanced Bionics to support patients who need help beyond the scope of hearing aids. Patients are unique, everyone having differing listening needs, different environments that they experience, and differing communication goals. With that in mind, a hearing aid could not be a one-size-fits-all solution. While the past decade has shown that RIC devices are by far the most popular, there will always be a need for a variety of models of devices to be available. The Paradise portfolio was first introduced a little over a year ago in August 2020. Despite its launch during a global pandemic, we have seen over 1 million devices fit within the first year of its launch, and this surpasses the quick acceptance of the ever-popular Marvel, its predecessor. Now, there are many reasons to love Paradise, though we won't have time to cover all of them today. When we think about what drives a patient to pursue amplification, there may be many factors at play, but of course the most important is to treat communication difficulties due to hearing loss. And this is why I always like to start discussions focusing on sound quality and hearing performance. While some of the other features, like connectivity and apps, they may be more fun, a little bit more trendy, an unrivaled sound quality is at the forefront of what makes Paradise so special. Research-backed Adaptive Phonak Digital 2.0 is the foundation of Phonak Paradise and its next-level sound quality. Adaptive compression speeds, linearized high-level gain, and the updated pre-calculation from mild to moderate losses provides you with an ideal starting point for your Paradise fittings. A preliminary study that was based in Oldenburg, Germany, found that APD 2.0 performed better than APD among experienced and inexperienced users with mild to severe hearing loss. The subjects reported less listening effort in noise and an overall preference for the natural sound quality of the updated APD 2.0 over APD. AutoSense OS, our automatic operating system, just got better. Designed with artificial intelligence, AutoSense OS 4.0 orchestrates all of the hearing performance features and programs to seamlessly adapt to any environment. With a strong foundation of automatic features, we're adding 3 new features: speech enhancer, motion sensor hearing, and dynamic noise cancellation. Speech and quiet often gets overlooked as an easy listening situation, and we spend a lot more time addressing speech and noise. However, we often need to hear soft speech, like someone speaking with a low voice or under a mask, or maybe even from the next room. So Speech Enhancer is a feature that can help patients in some of those more common environments where they still might have difficulties. Essentially, it's looking for soft, modulated signals in quiet environments. More specifically, this feature adds up to 10 dB of gain for those peaks of soft speech when the signal-to-noise ratio is 10 dB or better. This feature will activate for modulated signals like speech or footsteps, but not for unmodulated signals like fan noise. And that's how it is different from simply turning up the gain for all soft sounds by a fixed amount in the fitting software. Dynamic noise cancellation takes spatial noise cancellation to the next level. By working in conjunction with our adaptive beamforming technology, dynamic noise cancellation further improves the signal-to-noise ratio by up to 4 dB. What we see here in the third and fifth columns are the effect of dynamic noise cancellation when set at weak, which is the default. Now, all the way to the right, we see the impact of dynamic noise cancellation at its strongest setting when it is paired with our narrowest beamformer. But there's a little bit more to this story. We recognize that not all noisy environments are the same, and not all patients have the same preferences in noise. And sometimes, even the same patient may have different preferences and priorities in different environments. So to accommodate, we give a new level of patient personalization in the MyPhonak app. So by adjusting the speech focus slider while in a noisy environment, the beamformer will narrow and dynamic noise cancellation will strengthen, allowing the patient to focus on what's important to them at that very moment. Motion sensor hearing is driven by our new motion sensor chip, and it changes the way hearing aids react to noise. Historically, hearing aids focus on the environment around the patient, but not what the patient is doing. So if someone is sitting in the middle of a noisy restaurant, they have very different listening needs than if they were walking around in a crowded happy hour. The motion sensor chip is going to recognize when a patient is walking in a noisy environment, and within 6 steps, it's going to adapt both the directionality and the noise reduction to provide better speech intelligibility, improved spatial and environmental awareness, better localization, and a preferred overall listening experience. The classifier of AutoSense OS is always working to evaluate the environment so that once the wearer stops walking, it will seamlessly adapt and provide the most appropriate combination of programs for the situation that they are in. Both Marvel and Paradise support 5 different 2.4 GHz wireless protocols. If we think of each of these protocols as languages, it helps us to really determine what can be connected to the hearing aids. So if the hearing aid is one device, and we think about any other device it can connect to, we need to make sure that each of those devices are going to speak the same language. If they do, we're good to connect. So the first we'll talk about is Bluetooth Classic. This is a standard Bluetooth protocol, and it's used by millions of devices today. And we use this to support phone calls, video calls, and media streaming. Next is Airstream, which is a proprietary low-energy protocol that is used when connecting to the TV connector or partner mic. Roger is another proprietary protocol that is going to enable the incomparable Roger microphone technology. So this is an adaptive gain strategy, and it's going to go above and beyond partner mic and any other remote microphone system available. It's going to ensure that a patient is able to hear well when background noise or distance between the speaker and the listener is too great. Bluetooth Low Energy is another standard Bluetooth protocol, but this one is a Bluetooth LE, Low Energy, and what we use it for is the MyPhonak app. It also helps to enable connection with the remote support and also programming with our NoaLink wireless technology. Lastly, we have binaural voice stream technology. So this is our protocol that supports that full audio streaming between the hearing aids. And this is used for features such as speech and loud noise, Speech in 360, and Duophone. Made-for-all connectivity is possible because we utilize Bluetooth Classic and not the Apple proprietary MiFi. Apple is not the only manufacturer of technology on the market. It is one of many, many manufacturers that make devices that have connectivity. Universal connectivity allows a patient to seamlessly connect to their smartphones, their flip phones, their tablets, their computers, their smart TVs, their e-readers. I could keep going on and on. We first introduced universal connectivity 3 years ago with Marvel, and it really was a game changer. With Paradise, we take it to the next level. Paradise supports 2 active Bluetooth Classic connections. This means that when streaming media from one device, you can still receive notifications and answer calls from another connected device. So no more missed calls while streaming media. You can connect your personal phone and your work phone, or you can connect your tablet and your computer. 2 Bluetooth connections means less pairing and unpairing and more time to enjoy other things. Paradise makes it easy to seamlessly use multiple devices. Up to 8 classic Bluetooth pairings will be remembered by the hearing aids, with 2 of them being actively connected, as I mentioned. Paradise also supports up to 6 Bluetooth low energy pairings, so patients can download the MyPhonak app on their smartphones and tablets for control of their hearing aids no matter what they're streaming from. And all of those Bluetooth slots are in addition to the ability to use our accessories. The motion sensor in Audeo PR and PRT allows the hearing aids to detect and respond to changes based on the movement of the wearer. Tapping on the hearing aid, or the pinna, twice in succession is going to engage the motion sensor and register as a purposeful signal to the hearing aid, similar to pushing a button. This can be very meaningful for patients with difficulty pressing the multifunction button due to poor dexterity. Tap control can be customized and used to pause and resume streaming, accept or end calls, and even access a voice assistant like Siri or Bixby. Our most recent firmware update also added the ability to customize the sensitivity of tap control so that patients can truly customize this feature to their listening needs and physical abilities. The access to virtual assistants is really exciting. Think about your patients and how they want that ease of use. Maybe their phone is buried in their bag and they need to answer it. And if they tried to find it at the bottom, they're going to miss that phone call. So rather than having to find that phone, they can tap, tap right on their pinna and answer the call and not miss it anymore. And what about your patients who kind of know how to use their smartphones? I think we all have a relative or a patient that we can think of who falls into this category. For me, it was my mother-in-law. She would text me, and sometimes it was a text message, sometimes it was an email, sometimes it was a Facebook message. So with the ability to tap, tap, text Allie, it makes life a whole lot easier. This is going to open up a world of technologies for patients who might otherwise not know how to use it. Audeo P Life is a recent addition to the Paradise family, and it's an exciting one. It has been years since a waterproof device was available, and Audeo P Life is the first waterproof rechargeable hearing aid. While it's IP68 rated, and that is fairly common these days, the Life device was tested well beyond those classifications. The 8 actually refers to fresh water when we say IP68, but Audeo P Life was tested in salt water, chlorinated water, soapy water, and high heat with sweat. But it's a Paradise device, so no new features to learn about, just new hardware that is built tough. And we've done away with openings that moisture may have seeped into. No pin for the receiver, no battery contacts, extra protection at the microphone ports and seams, and a special coating for all of the internal circuitry and parts. This Parylene material is also used in implantable medical devices like pacemakers, as well as aeronautics. The idea is to give you and your patients the peace of mind around water to live their life. So you can sweat in the garden, oops, jump into the shower, or get caught in a rainstorm, and there will be no problem. Life is compatible with our standard SDS 4.0 portfolio of receivers, so no new receivers, domes, or earpieces to learn. It's currently available in the 90 level technology, but other levels will be available at a later date. Now remember, I said there were no battery contacts on Audeo Life, and this is because we're using inductive charging. Our typical charging method is very quick. Around 2.5 hours should get you that complete charge. Inductive charging is a little bit less efficient, so I would give it about 3 hours to get the job done. And another perk, removing the devices from this charger may be a bit easier for patients that have dexterity issues and struggled with the combi case. There is an onboard lithium-ion battery in the charger that will hold up to 3 full charges, and the lights between the hearing aids will alert you to how much charge the internal battery has. The lights on the hearing aids will let you know the status of the hearing aid batteries. With that, I want you to equate Phonak with easy-to-fit solutions that meet all of your patients' unique listening needs. For more information, you can reach out to your Phonak team, check out phonakpro.com, or email me. Thank you again for joining. My name is Allie Hoffman. My email is listed on the screen, and if you have any further questions or would like some more in-depth training, just let me know. I hope you're enjoying the conference and are enjoying the beautiful weather in Naples, Florida. Wish I could be there with you. Have a great day.